Now we're going to discuss some relationships between angles and side and triangles, and we're going to have two theorems. That one is just really the converse of the other one. They both describe the same relationship. Before we actually state these theorems, let's look at a triangle. And in this triangle that I've constructed, I have measured all three angles, and I have measured all three sides. And this is a scaling triangle. None of these sides are congruent, and notice that none of the angles are congruent either. And so in previous chapters, we learned that if two sides of a triangle are congruent, that guarantees that two angles will also be congruent, and that it's the angles that are opposite the sides would be the congruent angles. And we know that if three angles of a triangle are congruent, then all three sides are congruent. Well, we can point out here that if none of the sides are congruent, then none of the angles are congruent, which kind of follows from those other relationships that we've learned. And the reverse is also true. If none of the angles are congruent, then none of the sides would be congruent. So the question then is, where is the largest of the angles, and how does the position of the largest angle compare to the position of the longest side? If we look at this triangle here, angle B is the largest angle in the triangle. It's bigger than angle C, which is then bigger than angle A. Angle A is the smallest angle, and then angle C, and then angle B. Okay, then where is the longest side? Well, the longest side is the side that's directly across the triangle from angle B. We call that the opposite side, on the opposite side of the triangle. And so segment AC is the longest side, and it's directly across from the largest angle. Where's the smallest side of the triangle? Well, it's kind of close, but here this side is the smallest side. Where does that compare in position to where we find the smallest angle? Well, angle A was the smallest angle, which is over here, and then the opposite side from that is the smallest side. And so it appears that the largest angle is opposite the largest side, and the smallest angle is opposite the smallest side. And if I was to readjust this, let's make angle A be the largest angle. Let me slide point C over, and now I've made angle A is now the largest angle in the triangle. Now where's the largest side? Well, the longest side is the one directly across from it. It's side CB is the longest side in the triangle. And so once again, the longest side is the one that's across the triangle from the largest angle. And now where's the smallest angle? I made, let's see, angle C is 54.56, angle B is 51.67. So angle B is the smallest angle. Look where the smallest side is. The smallest side is the one directly across the triangle from the smallest angle. And so it appears that we could say that in a triangle, if the angles are not congruent, that the largest angle is the one opposite the longest side. And we could say that if the sides aren't congruent, that the longest side is the one opposite the largest angle. We could say it both directions. Well, let's take a look at this theorem then. The theorem here says, if I can find the right button to click, there we go. Theorem 5.9 says if one side of a triangle is longer than another side, then the angle opposite the longer side has a greater measure than the angle opposite the shorter side. So in other words, the largest angle, or the larger angle, is opposite the longer side. And then theorem 5.10 says it in reverse. If one angle of a triangle is a greater measure than another, then the side opposite the greater angle is longer than the side opposite the lesser angle. The longer side is opposite the larger angle, and the smaller side is opposite the smaller angle. So these relationships always hold true. They're important relationships, and so we have the angle side relationship theorems that are, again, just the converse of each other.